How does satellite station keeping work in orbit? Imagine trying to keep a tiny boat steady on a choppy lake. Satellites in space face similar challenges, constantly drifting due to various forces. That's where station keeping comes into play. It is the ongoing process of making small adjustments to keep a satellite in its designated spot. These adjustments are necessary because natural forces tend to push satellites off course over time. Satellites in orbit experience several forces that can change their paths. The Earth's gravity isn't perfectly even because our planet isn't a perfect sphere. This causes gravitational perturbations, which slowly shift the satellite's position and tilt. The Moon and Sun also exert gravitational pulls that can cause the orbit to wobble or tilt slightly. Solar radiation pressure is another factor. Sunlight pushes against the satellite, changing its shape and orientation. For satellites in low Earth orbit, atmospheric drag is a big concern. The thin layer of air at these altitudes slows the satellite down and causes it to gradually fall closer to Earth. To counteract these forces, satellites use onboard propulsion systems called thrusters. These thrusters fire in controlled bursts to adjust the satellite's velocity and position. The timing and strength of these burns are carefully calculated to correct specific deviations. For satellites in geostationary orbit, which stay fixed above one point on Earth, station keeping involves two main tasks. The first is north-south control, which manages the satellite's inclination or tilt relative to the equator. The gravitational pulls from the Moon and Sun cause the orbit to tilt about 0.85 degrees each year. To fix this, thrusters fire perpendicular to the orbit, nudging the satellite back to the correct tilt. This process uses a lot of fuel, often around 45 meters per second of velocity change each year. As the satellite ages, operators may stop north-south adjustments to save fuel, allowing the inclination to drift and requiring ground antennas to track the satellite's movement. The second task is east-west control, which keeps the satellite aligned with Earth's rotation. The Earth's bulging equator causes the satellite to drift east or west. To fix this, thrusters fire tangentially, adjusting the satellite's speed to stay in the right longitude. These maneuvers are less fuel-consuming than north-south corrections. Solar radiation pressure can also cause eccentricity or oval shape in the orbit. Operators manage this by firing thrusters to keep the orbit as circular as possible. Most satellites perform station-keeping maneuvers every few weeks. They stay within a small station-keeping box, which is a defined area of acceptable deviation. The forces acting on the satellite cause it to oscillate within this box naturally. The thrusters give it a gentle push back toward the center before it drifts too far. Modern satellites often use efficient propulsion systems like ion or plasma thrusters. These provide precise, low-thrust adjustments that extend the satellite's operational life by saving fuel. In essence, satellite station keeping is a continuous balancing act. It uses carefully timed thruster firings to counteract gravitational pulls, solar radiation, and atmospheric drag. This process keeps satellites in their precise orbits, ensuring they perform their roles in communications, navigation, and Earth observation without interruption.